she gets it.
Okay. I can say the prayer.
Awesome. Thanks.
Dearest Father in heaven, we give thee thanks for this opportunity and thank thee for this day, and pray you'll be with us as we go over these principles and we can expand our knowledge. We do love thee, and bless the many who are suffering, and bless each of us as we do our schoolwork and our families. In the name of Jesus Christ, amen.
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 Awesome. So we have 15 questions today. Did anyone have any questions about the homework? I mean, the lesson?
I have one question about the on that prep assignment, the very last question. You had to -1 from the z-scores, or yeah. Why did I -1? Is that because it was right skewed, not normal?
No, I don't think. I think it was because you had to find the opposite probability of the one you did the math for. So when you subtract 1, then you get kind of the right probability. Does that make sense?
Even though they're both the same number? Because I had to do 1 minus the same number, you know, and then I came up with a totally different number. So I just...
Let me pull it up. I don't remember that one specifically.
Yeah, I think it was the very last question, but as long as... I'm sure it's in the reading, I just missed it. Not this week, previous week. Are you looking at it? Is that what you're doing?
Yeah, I'm just pulling it back up.
Okay. That was the only one I kind of struggled. I got the answer, but I didn't. I only looked at the answer sheet. That's how I knew -1 was like, what am I minusing 1 for?
Come in.
You have the answer up in front of you.
I'm gonna have to run downstairs to get it because I don't have everything up here.
I'll grab it real fast.
It's in the. I got the same as the prep answer sheet only because I looked at it, but I got the two numbers that were 0.00, whatever that was, and then I looked at the answer sheet. It said 1 minus that number minus that number equals 0.788, I believe. If I'm remembering right.
You know, there's 3 different ways I guess you can find it. But the easiest way is just to type in the z-score and highlight the middle section, and that gives you the right answer.
Okay.
If you highlight the left areas and don't highlight the middle, then the area it gives you is 0.2113. And if you subtract 1 from that, it gives you the middle area, which is the answer. Does that make sense?
Yeah, it does. Okay. I think question 3 on the quiz is going to be the same kind of scenario then. I just pulled up the quiz. And do you see that that could be the same one? Same kind of deal?
Yeah, I'll have to look at it. Are we, is everybody ready then for the quiz?
Yeah, I'm ready.
Yeah.
So question number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of 1.358 and to the left of negative 1.358. So I'm just going to type in 1.358 and then highlight the left and the right side of that, and I got 0.175. Oh, are we supposed to do 4 decimal? No, yeah, 3 decimal spots. I got 0.175.
I got 1.744, but okay.
How did you get that?
I did on each side of the applet was 0.0872. That's what on my applet it shows. Then if I add those 2 together, I get 1.744.
So the number in there was the z-score, not the area.
Right. I put in the z-score of 1 point negative and the positive. But I mean, I don't know if we have to have the 3 decimals at the end or just is it 1.75? I don't know.
You mean 0.175?
Yeah. Is that, or do we have to have, like the example, 3 decimal points after?
I just did 0.175.
Yeah, 0.175.
Okay.
So I can do the next one.
Thank you.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? I'm gonna guess because I don't really know.
9 observations.
I don't know.
Me neither. I don't understand that one.
I don't know.
Smaller standard deviation.
So can we come back to this one?
Yeah.
I'm thinking about it.
I'll do 5. Which of the following results implies that the spread in X decreases as the sample size increases? And I think that is the law of large numbers.
I did this messed up last time, so I'm trying to pull up my what I answered last time. I got a few of them right.
Good.
And I had to contact Sister Limma and say, I messed up. And she goes, oh, well, I'll give you an extra try then. I said, okay, thank you.
Hey, that's good.
Otherwise, I would have had an F. This is like, it's not letting me pull it up. Not in this one anyway.
Okay. Well, any objections to that?
Nope.
No, I agree.
Okay.
So you got number 6.
Yeah, I got number 6. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? All right, let's figure that out. 150.8 equals number 2. I got 1.045.
Me too.
How did you do that?
I took the Diane score of 160 minus 150.8, and I divided it by the standard deviation of 8.8, and I got 1.045.
Where? Oh, okay. Okay. I didn't see the information.
Okay.
All right. What was it? What did you get?
1.045.
Okay, great. Thank you. Sorry about that.
You're welcome.
Well, cool. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay. So, type in the Z-score. Highlight the right section. 148 sound good?
0.148.
Which side did you highlight?
Right of the Z-score.
1.05. Okay, 0.148. Okay. Is that you got 0.148, right?
That's what I got.
Yeah.
Okay.
Is it mine? Is it me?
Yeah, I think so.
A random sample was selected to take the GRE. Their scores are 160, 175, 163, 149. What is the Z-score corresponding to the sample mean of these student scores? Just a second. Okay, so I'm a little confused. So I took the average of those scores, I added them up and averaged them. Calculate for that to find the Z-score.
Yeah, so that's your random sample variable or whatever they call it. And then you read like in the lesson how it says to do it a little bit differently with the sample number.
Oh, that's where you do the square root.
So I need to.
What's that?
Do I need to use this formula?
Mm-hmm.
That's in the textbook?
Mm-hmm.
All right, hold on. All right, I'm lost. I'm not sure what I'm doing.
This is what I got. I don't know if you can read that.
From.
Did anyone else get this as their answer?
I got 2.338.
Did I do something wrong? But it's this part's right, isn't it? At least.
Yeah,
Did I do that?
Equation's right.
Can you tell me where you got the 5 from?
So there's 5.
That's the random sample.
Yeah.
Oh, it was 5 numbers.
So why do you have 160? I'm confused too. Oh. The GRE is 150.8. And they have 5 different numbers there. Why did you pick the 160?
That's the average between all 5 of them.
Okay.
Ross, I got the same answer.
Did you?
160
Let me try it again.
minus 150.8 divide by.
So Mike was able to find the average of the those 5 students.
I got 2.3. Okay.
And then, so we want to find the Z-score, which is finding the difference between this average that we calculated and the actual average, the population average. And to do that, we subtract the 2 averages.
Yeah.
And then we divide that by the new standard deviation. And the new standard deviation is 8.8 divided by the square root of 5. If you don't have a scientific calculator, you can like find the square root of 5 and then, oh, you know what? You're right. I did do it wrong. I was timesing it instead of dividing it.
2.4, right?
Okay, hold on. 50 minus 150.8. Yeah, what'd you say?
338.
2.38, yeah.
So what is the square root of 5?
That's really hard math. I need a calculator for that.
I just use Excel.
I just use my phone sideways. Or you can use the scientific calculator. I have one here somewhere. And I think you can do it on the app on your phone.
I have a scientific one. I just don't know how to use it.
So if you have one on your computer, it looks like this. If you go scientific.
And then you do the square root.
Square root of 5. Oh wait, no, you type in 5 and then put square root. And that's the square root.
5.
Okay.
I need to fix my answer. I already typed it in.
I need to figure out how to use a scientific calculator.
That'll be good. 2.338. Okay, so 2.338 it is?
Yep. That's what I got.
Okay.
So that means the next question should be pretty simple.
Okay. So what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So you'll take 2.338, put that into the z-score, and highlight the right part. And it says to round to 4 decimals, so that would be 0.0097.
Awesome, that's what I got.
Yeah, I got it.
Repeat that one more time, please.
0.0097.
0.0097. I remember getting that answer last time when I was working on before.
There you go, you just got extra practice.
Yep, that one I didn't remember. Okay. But then I'm going to remember all these others. Okay. Use the following information to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5. Standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who were selected? Well, it tells it's left skewed, right?
No, I don't think so.
I think it would be approximately normal because it's a big sample size.
This is where I struggled with some of the homework.
So in your mind, imagine 2 different graphs. You've got this one, which is the population.
Okay.
And so this is all of the students. This is the whole population. And right here is, the mean, or is 3.5.
Okay.
So on the next one, they're saying we selected 81 students. We know that the population mean is 3.5, but what are the chances that these 81 students actually have a mean of 3.7 or something? So then we find this one has a new standard deviation. So this is the mean of means. Does that make sense?
Yes.
So if we do another study with just 81 students, that's when we use this formula up here. Oops, this one right here.
Okay.
So we would do like 3.6 minus 3.5 divided by the standard deviation divided by the square root of the sample size. So when it's what is the shape of the sampling distribution, of the random variable, that's asking what's the shape of this one, not what's the shape of this one. This one is less skewed, so it would look more like that. But since we have 81 samples, the shape of the sampling distribution is going to be normal approximate. And I don't know if that helped at all.
Yes, it did. Thank you.
Okay, good. Cool. Is it my turn then?
Yes.
What is the mean of the distribution of sample means for all possible samples? What is the mean of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population? I have no idea what that's asking.
I don't either.
Neither do I. It's a weirdly worded question.
Well, it would be 3.5, wouldn't it? Because the population mean is 3.5, which means that's going to be the mean on the mean of means. Yes.
I think so.
Because 81 is because of the central theorem, whatever that rule is, that makes it a normal, approximately normal, which means that the mean would be the normal mean, right? So it'd be 3.5.
I think so. Makes sense to me.
Hey, let's try it.
All right, let's try it. Good idea.
Let's try it. What 12? Number 12. What is the standard deviation of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population. I don't know. I don't understand.
Ross, do you have any ideas?
I'm not sure.
It's just asking for the standard deviation of the distribution of sample means. So remember how we talked about the two different graphs? So this is the first one. The second one is the distribution of sample means. This is the population mean, and then all these other plots along here are like sample means. So it's asking not what the standard deviation of this is, but what the standard deviation of this is if you have a sample size of 81. So I believe it should look like the standard deviation, which is 0.7, divided by the square root of 81, which is 9. And I think if you do the math for that, we should be able to find the new standard deviation.
Mm-hmm. What was that, Mike?
0.078.
Yeah, that's what I got.
That's what I got too.
0.8, that's what I got.
So 3 decimal spots, so you'll want to do 0.078.
0.078. Okay, that's what I always get confused when it has like 7777. Like, which one am I going to use now?
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So you have to just find the z-score for that. Using the two numbers that we just found, right?
I don't know what we're doing with this one.
So you have to find the z-score for that.
Okay.
And then basically find the area for what is less than 3.3. So you'll go to the left side of that applet.
And you put in 3.3?
No, that's the
That's the standard.
That's the sample mean.
yeah.
Okay.
So what they did is they took 81 students and the sample of that mean, the mean of those 81 students was 3.3. So we're trying to figure out what area what are the chances that
it was less than that.
Yes, exactly.
So I got an area of 0.0052. It's 3 decimals, so 0.005.
Me too.
I have to go back and work that, but I'll take your. I haven't put my head totally around that one. But I will. It just takes me longer sometimes to get some stuff. Is it my turn?
Yeah.
Okay. I probably have to help me with this one. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So if I just put that other number in, then we'd have the greater, right?
Just highlight the right of, yeah.
Okay.
Shouldn't it be the middle and the right?
Yeah, so anything right of negative 2.564, right?
Yeah.
So that's what I was doing. 0.005. Hold on. I didn't really like that score. So that's highlighting both sides. 0.096.
So highlight the middle and
Okay.
the right.
And the right. 0.5199. So 0.52. 0.52.
No.
Nope.
So you remember how last time we talked about you can subtract 1 to find the other. So in this case, you can look at the last answer. Before we wanted to find what was less than 3.3. Now we're wanting to find what's more than 3.3. So either you can highlight in blue the other sections and unhighlight the other one, or you can just subtract 1 from 0.005. But if you decide to highlight it, it should look like this. So if you look, the left side is not highlighted now. The middle and the right side are highlighted.
Okay. But what your z-score you put in 0.05?
No.
Is that right?
No. 0.005 was your area.
Okay.
You still have the same z-score though.
That's why I put it in the z-score, not the other one. Okay. So 0.99? You said to highlight?
995.
Yes.
Mm-hmm.
Okay. 0.95.
Awesome. For question number 15, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but raised after a tragic boating accident. The standard deviation is 26.7. The weights of random sample of 48, so N equals 48. Commercial boat passengers were recorded. The sample mean, so that's X with the bar over it, equals 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than observed in this sample. And we're going to round it to 3 decimal spots. So that would be 177.6 minus 185, and divide that by our new standard deviation, which is 26.7 divided by the square root of 48. What's the square root of 48? Yep. And then we can find the new z-score, and then once we find the z-score, we can find the new area or probability. So, I got my new z-score of negative 1.920. I'm going to type that in. And then I need to find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. So I'm going to highlight everything to the right of that z-score. Is that right?
I think so.
That whole extreme thing is throwing me off. As extreme or more extreme means that they are not only interested in values that are lower. They are not only interested in values that are lower than the ones observed, but also values that are far away from. What does that mean?
So I'm thinking it's maybe both sides of it, but not the middle.
Yep, I think that you're right. That sounds great. So I have an area of 0.055.
That's what I got.
Awesome. Let's scroll back up to number 4, and maybe we can get it after all those practice problems.
Did you say 0.55?
Mm-hmm.
Yeah.
To work at that one too.
So let me show you really fast, Catherine. Did you get the same z-score as us?
Tell me what your z-score was.
Was it 1.92?
Yeah, I got that part, and then but I didn't know what else to do after that.
So if you look at my screen, this is what it should look like, your probability applet. You'll type in negative 1.92, and we're trying to find the extremes, which means the less probable weight averages. So we're going to highlight this blue area over here and this blue area over here because this area is not extreme.
Okay, I got the same. Okay.
Does that make sense?
Yeah, I got it. I just noticed I put in the one number different on the z-score. I got it now. Thank you.
Cool. Awesome. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? What would make it smaller? Individual. It would be the distribution of individual means, because what's going to make it smaller? Let's look at the formula.
Yeah, the sample mean wouldn't change it that much.
Yeah, so this right here, this formula is the sample mean. Wait. No, I think I have it backwards. The distribution of the sample means. Yeah, I think I have it backwards. So this one, correct me if I'm wrong, the O shape, whatever, standard deviation is the one that would make it smaller. The following will have a smaller center. No.
Nine observations are random. Maybe that's part of the key. Maybe random is.
The distribution.
Well,
I think the first one.
I think it's the individual observation.
I think so.
Because doesn't the sample mean goes lower, doesn't it change? Because the standard deviation does go smaller.
Let's just try it.
Well, nope, it's actually not the right answer. But we got all the other ones right, so that's good.
What's the sample means or else? I think it's the sample means.
You can try that if you want, and if that's not right, then it's none of the above.
All right, I'll try it. Since I already had an F on one, I can.
There you go.
Let me save them and I'll submit it. It's number 4. Number 4 was right. The sample means.
Does anybody know why that is the case? Distribution of sample means.
Because, well, one is the X with the line above it, sample means. The other one is just the observation. Oh. Maybe that's the whole difference right there.
Yeah, you're right. I was totally overthinking it. Because we divide it by the square root of 9, so it's obviously going to be smaller.
Mm-hmm.
Will? Okay. It's good stuff.
Makes sense.
Makes sense. Ross, why couldn't we figure that out?
I don't know.
So,
Overthinking it.
what was the answer to 15? Because obviously I put in the wrong number.
Uh-oh. I
Point
don't.
055.
0.0. I put just 5.5. Okay. I messed up. And I messed up on one other one because it's saying I only got 15 of them.
What was the other one?
Let me look. Hold on. Where are you? Question 3. I put in the wrong number again. I had 1.75, but
It was 0.175.
point. When I put the point in the wrong other place. Okay. That's
All right. I've got to jump onto another group meeting.
Thank you. Thank you.
Sorry.
Thank you.
All right.
Thank you.
Okay, I'll see you guys next week.
All right.
All right.
Have a good one.
Okay.
Thank you.